Gosh, I find it really interesting that everybody's here early on a quiz night or a test night or whatever like that. Wonder what that means. Oh well. Um, Going to cover a lot of stuff tonight early on. I'll stop somewhere around this time, explain to you how the quizzes are going to work. Okay, and then we'll quit early and you go off and do the quizzes. But they are on mom, so you don't have to turn anything in, and that show work or add work feature that was on that previous quiz, that's not on this. All you're doing is putting the answers down, clicking submit, and going off and doing the rest of the quiz. So relax, it's not that bad. Okay, very quickly, yesterday in chapter 4, we talked about equations in or with two variables. And we said generally they have an infinite number of solutions. Generally, there's always an exception to every rule, but they will. So an example was, I don't know, 3x plus y equals 9 or something like that, okay? And one of the ways we find solutions to this is we build an XY table, a table of values. And you randomly, okay, that's what screws everybody up. You just randomly pick a value for X. Like, I don't know, X might be 5. And you plug it in. 3 times 5 plus y equals 9. 3 times 5 is 15. So if you take away 15, you get y is -6. So y is -6. And that generates the ordered pair when x was, the ordered pair xy, when x was 5, y was -6. Okay. Most people have been trained to always pick an x randomly. Pick an x, any x. Well, you don't have to. You could just as easily pick a y randomly. Again, the idea is you pick these numbers randomly. Okay. And so we plug in y is 5. So 3x plus 5 equals 9. Take away 5, 3x equals 4. Divide by 3, x equals 4 divided by 3, 4/3. Okay, and so that tells us the ordered pair is 4/3, comma 5. Remember, even though we started with the 5 randomly for the y value, plugged it in, got x, when you write the ordered pair, the x value always comes first, always. That will never change. Okay, and we can keep doing this. And like I said, sometimes mom will say, just pick some numbers. Other times mom will actually give you a number like, hey, if x is -2, figure out what y is. So just force it on you. Well, if x is -2, we have 3 times -2 plus y equals 9. That's -6. So you add 6 to both sides, you get y is 15. So we get 15 here, -2, comma 15. Now I know I'm going a little bit fast tonight, but I'm trying to kind of make room. So this is kind of what we did, okay? We could either randomly pick our own values, and they don't have to be the same. I just thought I'd be cute and pick 2 numbers the same, one for x, one for y, and see what happened. Or mom can force you. Mom can say, hey, I want you to start with x is -2, and you figure out the y value. And then the other thing we did last night is we plotted these points, okay, 5, -6. Okay, 1, 2, 3, 4, 5, -6. Da, da, da. Somewhere down there, 5, -6. 4/3, comma 5. Well, 4/3 is actually 1 1/3. So you go over 1 a little bit, comma 5. Okay, 1, 2, 3, 4, 5. So we're somewhere like that. And the other one is -2, comma 15. -2, well, it's way the hell up here. Okay. Now, what we're supposed to gather from this, last night I was real big on philosophy. Woo, philosophy. An equation has an infinite number of solutions. We've only found 3 of them for this equation. That's all we found, 3 of them. But there's an infinite number. So the graph is our way. The graph is our way of showing the infinite solutions. It's a picture of infinity, if you will. And what this is saying is any points, any ordered pairs, boom, 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 like that. Any ordered pairs that are on that line that we can see, our eyes automatically kind of made this line. We could see it there. Okay, so any point that's on that line would have worked in this table of values. Okay, so you're going to see a lot of instructors in the future say an equation can be a table of values. It can also be a picture in a line. These are all different representations of the same thing. Equation, values, line. Now over here on the line, we all get lazy. Nobody, and I mean nobody, goes dot, 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 dot. What we do is we just draw a solid line and we assume, and you guys all know what happens if you assume too much. We assume that everybody knows that when we draw a solid line, it's actually made up with zillions of little dots, but they're all so close together we can't see them. That's the thing that people forget to tell you. A line is actually a whole bunch of dots so close together you can't see that there's space between them, but there technically is. Okay, so that's kind of what we covered last night a little bit. Any questions on that? That's a quick review of what we talked about last night. Anybody got any questions on that? Okay, then we'll move on. This is one technique that mom will force you into graphing, just for practice, ordered pairs, that kind of crap. In section 4.2, I think it's 4.2. Yeah. In chapter 4.2, okay, we talk about graph with intercepts. Now, in my opinion, this is the best way. Okay, but let's talk about what an intercept means. And people have a kind of an idea, but it's a false idea. When we just draw a line, you know, whatever like that, okay, this is called the x-intercept because it crosses the x, axis. And this point here is called the y-intercept because it crosses the y-axis. So the x-intercept crosses the x-axis, the y-intercept crosses the y-axis. All right. Well, if you look at this, a reasonable value for this point here might be 3, 0. I'm just making that up. Go over 3, up 0. This might be 0, 4. Just again, I just made up those values, but they seem reasonable. Okay. And that leads us to a kind of important concept. Every single time you want the x-intercept, y is always 0. And every single time you want the y-intercept, x is always 0. Now, we're going to do more graphing. We're going to, talk about lines right now, but later we're going to go to parabolas and logarithmic and exponential equations and conic sections, ovals, circles, hyperbolas. And on all of those, I'm going to ask you guys the question, what's the x-intercept? What's the y-intercept? And so what you have to bring to all of those problems, okay, is when I say calculate or find or graph the x-intercept, you set y equal to 0 and plug it in and get x equals something. We don't know. And if I say find the y-intercept, we say x equals 0. Okay, and we plug it in and we figure out what y is worth. So it's still building a table of values. It's still building that table of values, but it's building them with specific values. It's building them with the intercepts. Now I'm going to do a problem in just a moment, but I don't want you to get too comfortable with this, because the next course you're going to take is trigonometry, Math 104. That theoretically is the next course most of you guys will take. And in trigonometry, you're going to graph sine curves. Okay. And we're going to ask you to find 2 or 3 of the x-intercepts. Okay. And even if you don't know how to do it now, those are all called the x-intercept. And how do you find all of them? Well, for all of them, the y value is 0. So you're going to plug it in and do your magic math and stuff like this. Okay. Up here, this is the y-intercept because it intersects the y-axis. And again, you plug it in and x is 0. And we don't know what y is. Okay, x is 0, something for y. Over here, okay, x is something we don't know, but y is 0. Same thing here, x is something else, but y is 0. So the concept of an x-intercept or a y-intercept isn't just for straight lines. It's for all kinds of curvy lines. Okay. One of the things I guarantee those of you taking pre-calculus, you'll end up with a function like this. Something like that. You're going to have to graph that function. By the way, f of x is the same as y. Don't get all scared. When they say f of x equals, they're saying the same as y equals. But this has a graph. And they're going to say, what's the x-intercept? What's the y-intercept? So my point of throwing all these things up here at you is to show you that this is not just a concept that we're going to learn now and then throw away. We're going to keep using it over and over and over again, the x-intercepts and the y-intercepts. So let's try a problem. Okay. I want you to find the intercepts, then graph. And we're going to use this equation, 3x minus 4y equals, I'll say, negative 12. Okay. Now, I'm going to work through this one first, so you have an example, then you guys can do another one. Okay. Real quick, you're going to set up your table again, and you might even be able to do this in your head. That's the beauty of this. And you're going to say, x is 0. To find an intercept, one of the intercepts, I plug x is 0. I plug it in. 3 times 0 minus 4y equals negative 12. This says negative 4y equals negative 12. I can do that in my head. The answer is y is 3. So my ordered pair is 0, 3. That is an intercept. Now, it's the y-intercept. How do I know? Because x is 0. There's that kind of reversal. When x is 0, it's the y-intercept. So this is the y-intercept. Okay, because I said x is 0. And then we do it again. We set y equal to 0. Okay, plug it in. 3 times x minus 4 times 0 equals negative 12. 4 times 0 is 0, so I have 3x equals negative 12. I can do that in my head. X is negative 4. Divide both sides by 3, so I have negative 4, 0. And I know that because y is worth 0 over here, this is the x-intercept. So sometimes mom would just say, hey, here's an equation. Give me the x-intercept. Or here's an equation. Give me the y-intercept. So you'd answer this answer or this answer, whatever. Okay. Sometimes mom will say, find the intercepts and then graph them. Well, that's pretty easy. Okay, we come over here. Once you have the intercepts, 0, 3 is right about there. And negative 4, 0 is right about there. Remember, technically, it's not a line, it's a whole bunch of dots, but we're all lazy, so we'll just go like that. And that's the line that represents this equation. And those are the intercepts. Now I'm going to have you do one on your own in a second. Any questions? You sure? Okay. So can I erase this graph? Does anybody need it? I'm going to put another problem over here.
I still need it.
Okay, I'll wait a second. I'll wait a second or two. And while she's copying it down, does anybody have any questions? Again, I'm talking fast. If you need me to repeat something or say it again slower, I'd be happy to.
Real quick.
Yeah.
For your table, like you just skipped the 3 times 0 step. That's what you did, right? It doesn't just drop.
Well, it drops out. Why? Because 3 times 0 is 0.
Yeah, that's what I'm saying. But you just didn't throw it down.
Yeah, I just didn't put it down there.
Okay, I got you.
Actually, that your question leads to another really good idea. What a whole lot of people do, is they don't even do this table. They just go, if x is 0, this drops out of the problem, and I can solve that in my head. Divide both sides by negative 4. So when x is 0, this drops out of the problem. I have an easy problem to solve. Bingo. If y is 0, okay, then this drops out of the problem. So I have 3x equals negative 12. I can do that in my head also, and we get that answer. Okay, now that only works for the intercepts. That trick there is only when you're trying to find the intercepts, because you're plugging in 0 and 0 makes our arithmetic really easy. But to answer your question, yeah, I didn't bother to tell you that 3 times 0 is 0. I just said it goes away. All right, can I erase the graph now? Are we okay?
Yes. Thank
Okay,
you.
sure. So I want you guys to, same thing, find the intercepts and graph this, and I'm going to be kind of mean. 3x plus 2y equals 9. So for that problem, find the intercepts any way you want. Okay, I don't care if you build a table or not, or do it in your head, and then graph the thing. Okay, so if we just build our little XY table again, and say if x is 0, we have 3 times 0 plus 2y equals 9. That's 2y equals 9 because 3 times 0 drops out. That's y is 4.5 or 4.5. Now I'm not writing the ordered pair, but it's implied 0, 4.5. Okay, actually, maybe I should write it. The ordered pair is 0, 4.5 or 4.5. I don't care, or 9 halves, whichever. But what is that? Is that the x-intercept or the y-intercept?
The y.
The y-intercept, because x is 0. Then we start again. If y is 0, plug it in. 3x plus 2 times 0 equals 9. Again, if you guys want to leave off the 2 times 0, or you want to leave off the 3 times 0, that's fine, because I understand it goes away. So we get 3x equals 9, so x is 3. So we have 3, 0, and that was the x-intercept. Is that okay for your work? For everybody?
Yes.
Okay, again, I'm skipping steps. I'm assuming you guys can do the arithmetic here and the equation solving. If you need me to slow down or explain something, I will be happy to. Okay, so then we want to graph this real quick. So when x is 0, y is 4.5. That's somewhere between 4 and 5, 0, 4.5, and 3, 0. And so it looks like my graph is something like that. And that's it. Did you guys notice I cheated? Up here originally I called this 4.1. It's actually section 4.3. You might want to go back and change your notes. I screwed up. Originally I wrote 4.1. It's actually section 4.3. Okay, so now you have 2 ways of graphing a line. You can just build a table and put in random numbers, or you can build a table and put in these specific numbers. X is 0, figure out y, y is 0, figure out x. So there's 2 different ways. We're going to come up with a third way in a minute, or 2 or 3. All of these are legit. I know you guys, those of you who had algebra in the past, you've all been taught about y equals mx plus b, something called slope-intercept form, and all that kind of crud. And that's good, but it's not the only way to graph. Don't get suckered in that, oh, I have to use this fancy way. There's nothing wrong with building a quickie table of values, plotting those points to get your graph. Okay? Sometimes this is the best, fastest way. Sometimes the other ways are faster. Your job as a student is to learn what works for you. What's the fastest, bestest, most accurate way, that's bad English, whatever, to graph a line and to answer whatever the question is. Okay, moving on. This time we're going to go, I don't know where we're going to go. This is chapter 4 point something. I'm all screwed up. Okay, so chapter 4 point, I'm not sure what this is. I'll figure it out later. We're going to talk about slope. Slope of a line. Now, slope measures, it's a measurement of how slanted a line is. Okay, now we have this fancy formula that you do need to know. Okay, you do need to know this formula here. M, which I can't write, M equals, now M is the mathematical symbol, shorthand symbol for slope, a lowercase m, which I seem to be having problems with. Lowercase m equals. Now we write this. Okay. And again, this is y sub 2 minus y sub 1, x sub 2 minus x sub 1. I'm one of the very few instructors that make a big deal about this. Y sub 2 is not the same as, oops, y2, which is what people say, and it's not the same as y squared. They're all slightly different. This is called y sub 2. And I believe I'm the only person in the world that keeps talking about it in the correct format. I call this y sub 2. Everybody else, including math instructors, call this y2 minus y1. Okay, so I'll keep doing it my way. You can call it whatever you want. Doesn't matter. Okay, it doesn't matter. But I'm going to keep correcting you, okay, about the proper thing. This is called y sub 2. One of the reasons it's called sub 2, if you go look in your word processor, okay, and like you write, let's say you write x5, and then you highlight this on your word processor in your computer, and you go into the font and you select something called a subscript. Subscript. And you click that on your word processor. What's going to happen is you're going to get X with a little 5 down there. It's called a subscript. And believe it or not, an exponent, what we think of as exponents, those are called superscript. So my extreme anal need to call this sub 2 actually comes from the proper vocabulary. It's called a subscript. X sub 5, Y sub 2. Okay, enough. All right, so the most common thing we do with this is we give you 2 points. So for example, I might say, here's point A, which is 5 comma negative 1, and point B, which is 7 comma 3. And I want to find the slope of the line from A through B. What's its slope? Okay, and I'm going to show this in a couple of different ways. Well, mathematically, the formula says m equals. Now, y sub 2 literally stands for the second y value. So if we call this number 1 and we call this number 2, when we say y sub 2, we're saying take the second y value, 3, minus y sub 1. That's literally the first y value. Now be careful. That's minus a minus 1. The first y value is a negative 1. The formula has a minus in it. You just got to deal with it. The formula has a minus. So you pop the numbers in there. Over x sub 2. That means literally the second x value, 7, minus x sub 1. That's the first x value, 5. Now you clean this up, you get 4 over 2, which becomes now 2 over 1, and there's a reason for that. In all the other times I've been yelling and screaming, saying, no, you can't do that, because you got to reduce that to just the whole number, 2, except for slope, because slope measures something else. Slope measures rise and run of your line. I'll show that in a minute. So the numerator here is the rise. The denominator is called the run. And I'm going to show you that when we plot this. So if we go 5, negative 1, somehow here, I'll get out of the way in a minute. What that says is, for this line, okay, there's the line, and those are the 2 points that were on that line. Okay, what we're telling everybody is the slope is 2 over 1, 2, basically. What we're saying is to get from one point to another point, you go up 2, 1, 2, and go over 1. Okay. Then you go up 2 more. Well, I'm doing this wrong. 5, negative 1. What am I doing wrong? 7, 3. Oh, it should go up 2 over 1. Okay, up 2 over 1. Anyway, I'm doing something wrong, but it lands us on the other point. So what we're saying is, starting at one point, if we go up 2 and over 1, run means go sideways. I'm doing something screwy and I don't know what yet. Okay, if we go up 2 and sideways 1, we'll go from one point to the other point. That's how they're connected. As a matter of fact, we can go from any point to any other point. We can go up 2, 1, 2, over 1, and we'll land on another point on that graph. Always going up 2 over 1, we'll keep landing on the line, which is a point on the graph. So the thing that's true about this line is its slope is what we call constant. The slope never changes. It's always this. That's one of the neat things about when you get into calculus. We study curves like that. And in calculus, we say, whoa, wait a minute, the slope keeps changing. Here, the slope is this way. I froze, didn't I? Can you guys see? Yeah. Am I frozen or not? Or can you guys see me?
You're not frozen.
Well, I am on my screen, so I'm going to keep talking. Damn it. God. Okay. I'll probably screw this up. Come on. Well, as long as you guys could see me, fine. Okay, I'm frozen. I have a nice picture of my back. Yay.
It looks fine on our end.
Okay, all right. This is gonna make tonight kind of weird. In calculus, we'll study curves that look like this. And what's going to happen is this will have a slope here. This is a positive slope. And then here at the very top, that'll have a zero slope. And then that'll be negative. And so in calculus, we measure the slope of curvy lines. And ultimately, it's based upon this formula. Okay, ultimately it is, but it takes a whole lot of trickery to get us from here to calculus. So, but this is the formula you need to know. So, assuming you guys can all still see me.
Professor, I have a question regarding that. You put in that problem 3, the y sub 2 multiply y sub 1
No, subtract.
subtract. So if in the because the y
Okay,
sub 2 it was 3 minus 1.
right. So we go 3 minus a minus 1. That's subtract 7 minus 5.
So 3 minus 1 it will be 4.
4. 7 minus 5
Negative,
is,
negative, it goes negative and negative turns positive.
that's correct.
Okay, thank you.
Okay, and then we always reduce that to 2 over 1. Okay? Is that okay or not?
Perfect, thank you.
All right. So I want to put 2 problems up here and have you guys work them out and hope the screen doesn't do something bad. Okay. On each one of these, I want you to find the slope. So for problem number 1, let's say the point A is -3, -5, and the point B is 7, -2. That's problem number 1. Problem number 2, let's say point A is 5, 6, and point B is 5, -3. So for both of those problems, okay, I want you to find a slope for each one of these problems. And so if we go to this problem here, okay, and by the way, it's arbitrary. I'm just going to call this one number 1 and this one number 2. Okay, so if I go y sub 2 minus y sub 1, I get -2 minus a -5, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, again, it's minus. The formula has a minus in it. So now we do our arithmetic and minus minus becomes plus. So this is -2 plus 5. So this is 3. And this is 7 plus 3. So this is 10. So for this particular problem, for these 2 points here, we would say the slope is 3 over 10. Okay, is that math okay with everybody?
Yep.
Yes.
Okay, pretty easy. Now we do this one. Okay. And again, it's strictly arbitrary. I'm going to call that number 1 and that number 2. Okay. If you reverse them, okay, if you call this one number 2 and this one number 1, it's okay. Your steps in here might be a little bit different, but in the end, you should get the same answer. Okay, they'll all work out in the end. Okay, something. But if I'm going to go y sub 2 minus y sub 1, so m equals -3 minus 6. That's no second y minus first y, and 5 minus 5. That gives me -9 over 0, which is undefined. Or we say there is no slope. Okay, that's really kind of important. We talked way back in chapter 1, and that might show up tonight on the quiz. A 0 in the denominator means your denominator or your fraction is undefined. Now, Mom, the correct math is to say undefined. Mom wanted you to write DNE, does not exist. Okay, but the concept is still undefined. All right, I want to look at that for a second because that's kind of tricky. That's kind of tricky. All lines have a slope. Some are slanted this way, some are really steep, some are really flat, some are slanted this way. Okay, except this one is weird. So let's look at that line. Okay, if I plot those points, 5, 6, 1, 2, 3, 4, 5, 6, good enough. Looks like that. And I go 5, -3. Close enough. Okay. Now I need you guys to kind of pay attention here. This is a weird trick line. I talked about this a little bit last night, but it's those trick things that math always throws at you. You know, they're not happy with giving you the basics. Oh no, we've got to figure out ways that we can really trick you and screw you up and do all kinds of things. This is a vertical line. Okay, it's creating a vertical line. We just figured out over here that it has no slope. That's the mathematics. It has no slope, or the slope is undefined. Okay, but here's the catch. It's equation. Every line we give you has an equation. Every single line, no matter how we draw it, every single line in math has an equation somewhere. This line, and you don't have to do any work at all, you can look at it. This is the line where x equals 5. Every single point you pick here, every single point, okay? Pick a point. This is 5, 0. Pick a point up here. This is 5, 10. Pick a point down here. This is 5, negative, I don't know, 23 or something screwy like that. This is a special line, a vertical line, and you don't have to do any super formula or anything. You can look at it and you go, every single one of the x's is a 5. So its equation must be x equals 5. Must be. Okay? It still has no slope. There's a difference. The slope and the equation are related to each other, but they're not the same. A vertical line always has no slope, but a vertical line always has some equation. Okay, vertical line, no slope. Vertical line has an equation. Okay, I want to do one more thing and then I quit. I'll stop early so I can give you guys a lot of time to do the quiz. I want to talk about one more thing tonight. And again, my screen is frozen, so I sure as heck hope I'm talking to you guys. Any questions about what I said so far?
Hey, Professor, I have a question about the slope.
Yeah,
So when we finally salute all the question, does the final number is kind of like a rate or something?
Yeah.
Kind of like the angle talking about the X and Y, right?
in a way, yes. It's saying how much does the Y value change as the X value is changing. That's what rise over run actually means. The Y value goes up a certain amount, the X value goes over a certain amount. Okay.
Okay, yes.
And you're right, it is that rate. And if we turn that rate into a decimal and then do percent, we can get a percent answer out of it. But we just leave it usually as a fraction. Okay. So if we say, matter of fact, that's going to lead into our next one. If we say the slope is -2/4, or let's call it over 5. Okay. I just made up a problem. And I tell you the slope is -2/5. Well, what that says is, assuming let's start here, and I just made this point up, just as a starting point. In a minute, I'll be more specific. Well, this says I want to rise -2. Well, if you start there, how do you technically rise -2? Well, you go down 2. And I want to run. Run means horizontal. Okay, so rise means go up and down from your starting point, wherever that is. So I'm going to go down 2, but I'm going to go over 5. And that tells me this line looks something like that. From wherever we started from. From wherever we started from, okay, we rise -2 in this example, and then we run +5. Run means move horizontally. And so you're right, it's a ratio, it's a comparison. It's kind of a measure of the angle that it makes. Okay, now you started asking the question and I started talking. Are you okay with all this?
Yeah, I kind of understand now. Thanks.
Okay, anybody else? Is that okay? Well, that leads us to then the last concept I want to worry about tonight. There's more, okay? And you guys have a whole lot of stuff you can be doing over the weekend in chapter 4. But they're going to talk about in section 4.4, chapter 4.4, they talk about slope and this formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But they also talk about this example. Graph the line that passes through, oh, I don't know, I'm going to make up a point. 4,7 and has a slope of, we'll be nice right now, 2/5. So this, some of your mom homework is going to be something like this. Okay, it's going to give you almost a word problem. Graph the line that passes through the point 4,7. Okay, and that's the slope of 2,5. Well, I find doing this particular problem on mom kind of awkward. Okay, I find that I'm better doing this on scratch paper first. I'll show you why. So we're going to start at 4,7. 1, 2, 3, 4, 7, wherever that is. Okay. Now, we're going to rise to, that means we're going to go up to, and we're going to run 5. Now, when we say rise, we mean go up or down, because you can rise negatively. When we say run, we say you're going sideways, run sideways somehow. So from this point, we're going to go up 2, and we're going to go over 5. 1, 2, 3, 4, 5. Now, you're going to need to calculate what that point is. And that kind of confuses people. Okay. When we go up or down, who changes? Does the X change or does the Y change? When we go move up or we move down, who
Y.
changes? The Y value. So what you just told me is the Y value will change by +2. So let's go over here. We have 4, 7. We're going to take the Y value and change it by +2. Now it's going to become 9. Okay. When we go sideways, who changes, the X or the Y?
X.
The X changes. So the X value is going to change by 5. Okay. So 4 and 5 is 9. So this new point here is 9, 9. I went up 2 over 5, but I started here at the black point, up 2 over 5. Excuse me. That changed my X's and my Y's. So I have this new line. Now remember how Mom wants you to graph. To graph in Mom, and by the way, I don't know if you look on Canvas, but there's a little video that I posted up there that shows how to graph on Mom. It's kind of what I was talking about last night. But the first thing you do is you pick the fact that I want to graph a line. And then you put your cursor, you click on the first point. Okay, where you click on that. And then you move your line, you kind of rotate it with your mouse or your cursor or whatever like that until it goes through this other point. So it'll just, Mom will just take a line and it'll just throw a line up there like that. And you go, no, 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 no. And you have to rotate it down until it goes through 9, 9. So you've got to kind of move it until it matches that. And that's how you're going to graph that. So graph the line that passes through 4, 7 and has the slope of that. You get a rise 2, run 5. So you're going to have to figure out this extra point over here. And how did I do it? Off on my scratch paper, I said when I rise 2, I change the Y value. When I run 5, I change the X value. Okay, and that's how I get that new point. But again, look at the video. Sometimes explaining what to do on Mom is more confusing than actually just getting in and doing it. But I made a video, or I stole a video from somebody. Maybe I made it, I don't remember. I know I stole one somewhere. Well, whatever. Okay, on how to graph on Mom. Okay, so that's going to be the thing. What time is it? Wake up. Huh. Most useless thing in the world. I emailed you guys over the summer and said I ruptured my Achilles tendon, and I did, and it was one of the most painful things I've ever done. And I was out working in the garage when I did this, and I didn't have my phone with me, didn't have anything. So after I kind of got control of myself, because I was in really good pain, I ended up crawling into the house, where I kind of called for my wife after I crawled into the house, said, "Dear, we have to go to the emergency room." And she was binge watching some TV show or something like that. And she goes, "No, not now." And I go, "Yeah, I think so. Now we need to go." But when that happened, my daughter got very, very concerned, you know. So she went and she bought me a Apple Watch. And I couldn't say no because, you know, I understand. She gave it to me. I can call on it. I can do all kinds of things. You know, it actually has one of those features or help, I've fallen and I can't get up. It's got that kind of thing on there also. So she bought it for me out of love, okay, and she was afraid for me, whatever. But it's the most useless waste of money I've ever seen in my whole life. Okay, I got to charge it every night. Okay, I got to shake my arm to be able to read the time. Okay, it's what's up? It's $250 or 240 or something like that. I don't know. Give me a $19 Timex. I'm happy, but I can't tell her that. So if you ever meet my daughter, don't tell her that, please. Okay, last thing, and then I promise we're done. We'll take the quiz. We'll start it early. I promise that. The last thing in this section, 4.4, is the thing that most of you remember. It's called slope intercept. And slope intercept means you change it, you change your equation, and I'm going to give you an example to look like this. Y equals mx plus b. This is called slope intercept form. When you manipulate your equation, somehow using your algebra skills to make it look like this. Key idea, y is totally by itself. Totally by itself. When you do this, okay, you've manipulated the problem. It's in slope intercept form. So this number right here is the slope. Always, it's the number in front of the x. And this number right here is technically 0, comma b, but it's the y-intercept. Okay, it's the y-intercept. So let me show you how you do this. Let's take an easy equation. 3x plus 2y equals 6. So I want to manipulate it from this form of an equation into this form, which means I got to get y by itself. So what I'm going to do here is take away 3x from both sides of the equation. So I'm going to have 2y equals negative 3x plus 6. Okay. Notice the x has to come first, mx plus somebody. Now I have to get y totally alone. So I'm going to divide everybody by 2 because I got to get that y completely alone. Am I in the glare here? I can't see myself at all. No? Okay.
It looks fine.
All right. So if I go one step down, am I okay? Y equals negative 3/2 x plus 3. Can you guys all read that?
Yep.
Okay. Then what we've just done, what I've just done, is I've manipulated this equation, this formula, if you will, into slope intercept form. That's what that's called. When you get y totally by itself, y equals mx plus b. By manipulating the equation algebraically, now you can look at this. And you don't have to do any arithmetic. You don't have to do this y sub 2, y sub 1 crap. You don't have to do any of that. And you can say, aha, the slope of this problem is negative, 3/2. The slope is negative 3/2. because it's the m value. Okay, and the y-intercept is technically 0,3. It's that number right there. Okay, and I'm willing to bet that about 95% of you learned something like that back when you first took algebra, a long time ago. So we take an equation, we get y totally isolated. Okay, and from that, without any other work, we can tell you what the slope is. Okay, and we can tell you what the y-intercept is. Now remember, slope always stands for rise over run. That's how we use it. So let's have you guys try this one. Tell me the slope and the y-intercept, spelled very crappy, of this problem. Negative 2x minus 7y equals 19. Negative 2x minus 7y equals 19. Tell me the slope and the y-intercept for this equation. Should have put it on pause. Bummer. So I'm going to add 2x to both sides. We're going to get negative 7y equals 2x plus 19. It's ugly, but I'm going to divide everybody by negative 7. And I get y equals negative 2/7 x minus, because that's a negative 19/7, just to clean it up. Okay, that's called slope intercept form. And that brings up an interesting problem that nobody's asked me about. It might be too late now. So for this problem, the slope was negative 2/7, that number, and the y-intercept was 0, negative 19/7. Is that okay with everybody or not?
Yes.
Okay, so again, in section 4.4, Mom is going to ask questions about, going to give you an equation, ask what's its slope, what's its y-intercept. And when it asks those questions, all you have to do is your algebra to manipulate it to here, and you just pick the information off without too much more work. It's pretty easy. It's pretty slick, actually. Any questions?
Yeah, the negative is always the numerator.
Good question. No, that's what I was waiting for somebody to ask. Okay, good question. And I hope you guys listen up on this. Okay, it turns out in arithmetic that the fraction negative 2/3 is the fraction 2 over negative 3 is also the fraction negative of 2/3. Okay. Or I think I had, what was it? What was my slope? 2/19? Or 5/19?
Negative 2/7.
Negative who?
2/7.
2/7? Okay. Okay. It turns out in arithmetic that you, the mathematician, you, the person writing, can move your negative sign to the numerator, to the denominator, or smack out in front. And they're all correct. They're all correct. Okay. Now, for slope, we usually don't like those two. We don't like the subtraction of the minus sign right in the middle. But for slope, numerator or denominator, it doesn't matter. They're both correct. I would tell you that traditionally, we like the negative sign in the numerator, but you don't have to do it that way. Okay, so your question is really, really cool. You can slide the negative sign in a fraction, numerator or denominator, just kind of at whim. It doesn't matter. You're okay. Either one is acceptable. So that was a really good question. Thank you. Anybody else? Okay, then again, this is going to be kind of tough because I can't see what the heck I'm doing. So as long as you guys can see me, we're okay. So in a few minutes, I've got to go in and change a setting in Mom. But in the chapter 1 folder, you know, where all the chapter 1 homework was. Whoops. In the chapter 1 folder on Mom, this is Mom now. If you go down to the bottom, or near the bottom, I should say, you'll see chapter 1 quiz. Now it's not there now because I haven't turned it on. I got to get in and do that. Okay, which I will in a moment. But the chapter 1 quiz has 25 questions. Okay, you'll have 1 hour. Okay, and you do not have to show any work. You just do the problems. Okay, you're allowed 2 tries on each problem. Okay, but again, I've got to get in and make and turn it on. It won't be there. If you go to Mom right now, you won't see it. Okay, when you're done with that, then you go in the chapter 2 folder. Okay, and you look near the bottom. Okay, and you'll see a chapter 2 quiz. Okay, and it has 12 questions, which I can't spell. I think it would be good. Again, you don't have to show me any work. You just have to put the work in the little box, just like you did for all your homework. It asks a question, you put your answer in the box, you hit submit. Same thing. Okay, so chapter 1 quiz at 25 questions, they're all pretty basic. I mean, some of them are like, reduce this fraction, add these 2 numbers together. I mean, they're really basic. Chapter 1 was pretty basic. Chapter 2, some equations to solve, that kind of stuff. Okay, and again, you won't see any of these. If you're ignoring me right now and you've gone off to Mom, you won't see these because I've hidden them. I've got to get into my computer and fix them up. However, you must be completely finished by 11:59 p.m., basically midnight. So if you wanted to spend a few minutes kind of studying, going over your notes before you start, cool. But once you start the chapter 1 quiz, you got an hour. Okay, and again, that's 2.5 minutes a question, something like that, but they're really easy. Okay, and like the last 2 semesters I've given this, people finished everything in both of them in less than an hour. Okay, so it's not that bad. Go to the chapter 2 folder, go near the bottom, you'll see a chapter 2 quiz. It's got 12 questions on it. I would point out that the questions are random and every person is going to get a slightly different problem. Okay, so if I said quit now, go to mom, could you guys do this? Anybody have any hesitation at all?
This quiz of chapter 2, it is timed too.
Oh, it's 1 hour, yes, but it's only 12 questions. So you should be, I'm sorry, thank you for clarifying that. So you should still be okay. Piece of cake, easy. Okay, we okay?
These are both due
Yeah.
tonight,
Yeah.
right?
They're both due tonight. You got to finish by 11:59 tonight. Okay, so we have, well, 4 hours almost, okay, to do them all, but you have to do 1 hour for each one, but you've got 4 total hours to do some studying, to check your notes, and then to get started and finish. Anybody else? We okay? You guys think you got it? Now, here's the thing. You don't have to stay logged into Zoom. I'm not yet. I'm not the teacher yet that makes you do all the work in front of me on Zoom. Mostly because my stupid Zoom just froze. So, but that's a different issue. Even if it didn't freeze, I wouldn't make you do that. So if you want to log off of Zoom in a few minutes, not right now, go to mom and just do it. You're done. That's it. You can do that. If you want to stay on Zoom, that's okay. What I'm going to do in a few more minutes, as soon as I open up mom, okay, is I'm going to log out of Zoom and then log back in. So if you have questions, you can talk to me and ask me on Zoom. I'll stay on Zoom till about 9 o'clock tonight. Okay, after that, I'm going to go to bed. Okay, are we all clear? Is that okay with everybody or not?
Sounds good.
Yeah, everything okay.
Okay, don't go away yet. Let me get on my other computer and change the settings on mom. Don't go away. Okay. Boom. Okay. Chapter 1. Okay. Settings. What time is it? 7:51. I'm going to set it for 7:55, which is in 4 minutes. 7 : screw it. I'm going to set it for 50, which is right now. Same thing with quiz 2. Screw it. Save changes. Is anybody in mom and listening to me at the same time?
Yeah, the
Yeah.
quizzes are there.
Yes.
Huh?
They showed up.
Okay, so I'm going to